Hey Chris, decompositions, buddy, definitely challenging. I even found them challenging. Here's kind of, after we do the decomposition, here's what the example is telling us to do, and here's the step that you asked. I'm going to get to that in a sec, but a couple of quick tips, if you will, that I've kind of found that help me out. Number one, it's difficult when you multiply all of this mess by the LCD. You get a lot going on, but just remember the convention of algebra. Put the coefficient first and then the variables in alphanumeric order, right? So that means like if I was going to write something out, I would write 3cx, right? Where I'm writing the coefficient, the number, then the variables in alphanumeric order. So it comes earlier in the alphabet, it comes first. And that cuts down on a lot of confusion right there. The second kind of quick tip, after we do this, after we multiply everything by the LCD and we get a nice equation, basically if we make any number that's below A or B specifically, if we make that 0, we're going to end up solving for A. So if I make x 0, we'll end up solving for A in that instance. The second step, I'd basically take this little expression, 3x plus 4, 3x plus 4, and if we wanted to equate that to 0 and just solve using algebra, 3x would equal negative 4. Therefore, x equals negative 4 thirds, right? So if we say x is negative 4 thirds, inevitably we'll end up solving for b. So again, that's just a nice little trick. Just, I help it just keeps me focused on what I'm doing at the time because it is quite easy to get overwhelmed. Okay, so we've done that. We're punching in now. We know that a is 1 over 16 and b is negative 27 over 272. Now, how the heck did they come up with this? Well, what they did was they started with that original equation, which I'll try to write it down. Just bear with me. Feel free to skip ahead because it's like watching paint dry, and I don't want to make a slight mistake right here. Because as you know, you make one little mistake and your whole page of work is ruined. We got it all wrong. Okay? Plus cx plus d times x times 3x plus 4. Let's write that in there. 3x plus 4. I'll put that up here. I'll probably miss that now because I wrote it weird. Okay, so what they did, we're going back to this. Now we know that a is negative 116, so I'll just write that in. Or actually, sorry, a is 116. And I also know that b, I'll write it in red here, is negative 27 over 272. Okay, and I'll use brackets. There's an X there as well. So what they did then was we're going to do a whole bunch of order of operations, right? We're basically going to FOIL these two binomials, and then we'll multiply that result by 116. Over here, we're going to distribute, which is cool, I guess. And then over here, we could FOIL this and then multiply it by X, or multiply it all by X and then FOIL it, I guess. It doesn't really matter. That's what they've done. So I'll go ahead and just work through that, buddy, if you don't mind. So 116 times, now I'll do this in blue, we're just going to FOIL these out, right? We have 3x times 2x squared. That's going to be 6x cubed. We'll do our outsides. So that is going to be plus 12x. We'll do our inside, which is going to be plus 8x squared. And we'll do our last, which is plus 16. Over here now, I'm just going to forget this positive because I'm basically going to multiply by a negative. Now over here, it's probably easier to look on the on the diagonal, right? So 2 over 272, well, if I divide 2 by 2, I get 1. If I divide 272 by 2, I get half of that, which is 136. So when I multiply this out, I'm just going to write this as negative 27 over 136, because again, right here in this diagonal, right, that would be a 1. This would be half of that, which is 136. That should be a 6. And we have x cubed right there. I know that's a super mess, but we have x times x squared. Same thing with the 4 now. Let me do that out. Now 4 divided by 4 is 1. 272 divided by 4 is 68. So this is going to be minus something over 68. Remember, this is now a 1, so that's going to be a negative 27. And we had an x there as well, so that's going to be our x term. Okay? So that's that for now. Let me do the rest of this part in red over here. What we're going to have here, if I FOIL this out, I'm going to have cx squared plus dx. So that's in brackets right there. That takes care of this mess. And now I'm basically going to FOIL that by this 3x plus 4. So if I do that out, and I'll see if I can do it. No, I'm super out of room. Like, it's so tough to do this level of math here. Let's just let me see if I can just let me simplify what I have so far, buddy. Let me just parking lot this for a sec. Okay. Let's go back to the left here, just for my sake. I know it's probably a little confusing to think like this. But now we're just going to multiply everything by 1/16 and reduce, right? So this would be 6 over 16. I could do the half rule there. Half of 6 is 3. So that's going to give me 3/8 x cubed. 3/8 x cubed. When I distribute over here now, 12 over 16, that's going to give me a half, right? Because I can divide, is it 12 by 16? No, that's going to give me 3/4. Plus 3/4, just putting it in lowest terms there. 3/4 x. And then that's going to give me a half x squared, and then plus 1, right? So that's that all distributed right there. I just did this step right here. Boom, boom, boom. Okay, now we have all this mess over here. We just have these like terms, which I'll try to group them around here. So I'll just write it in here, buddy. I have negative 27 x cubed over 136 minus 27x over 68. Right, so that's going on, and now I'm just going to erase all this because I need the room, frankly. Okay, so let's FOIL this out here. We're going to have cx squared times 3x. So let me throw that in as plus 3cx cubed. So again, I'm just following my convention, right? There's a 1 here, there's a 3 here, that gives me 3, 1 times 3. There's a c, that goes first, and then I do my x's. I'll do my outside now, which is cx squared times 4, so this is going to be plus 4cx. I'll do my inside, plus 4cx squared, sorry. I'll do my insides now, dx times 3x, so that's plus 3dx squared, and then I'll do my last, which is going to be plus 4dx. Okay, so right now, I know this is a super mess, but I just have a ton of terms here, like so. So what did they do? Well, look what they did. They took all of the x cubed terms, which might be a bit hard to see, but they just grouped them up here. That's how they did that, Chris. So I have, let me get my highlighter here. I'll highlight the x cubed terms. I have 3/8 x cubed. I have negative 27 over 136 x cubed, and I have 3cx cubed. And you can see those are the terms right there. 3/8 minus, and then plus 3c. And all they did was they just factored out the x cubed, right? That's all they're doing right there. They similarly repeat that process with the x squared terms, right? So if I got a different color here, let me do yellow, right? All of our x squared terms, get rid of that. Where's our x squareds? There should be an x squared right here. I missed that on the 1/2, by the way, but there should be one there. Such a mess to hunt through, eh? Where else we got x squareds? We got x squareds here. We got x squareds here. That kind of thing. So that's where it gets at right there, Chris. They have the half plus 4c plus 3d. That's all they're doing. So they're just grouping them up at this point, and then factoring out the variables. So we know we have all our x cubed, all our x squareds, all our x terms, and then we still have that 1 floating around right here, which will eventually cancel with that. So I hope that helps, buddy. Super complicated stuff. More tedious than anything, really. Take your time. Keep asking great questions. And let me know if I can help you again.